In 1972, a group of scientists at MIT published a report commissioned by the Club of Rome. It was called The Limits to Growth. Its conclusion was unsettling: if the global economy kept growing at its current pace, consuming resources and generating pollution, the system would collapse before the end of the 21st century. The report was a scandal. Economists attacked it fiercely. Growth has no physical limits, they replied. Technology and innovation always find substitutes. Malthus predicted collapse in 1798, and here we still are. The limits to growth is just Malthus with computers. 50 years later, global temperatures have risen more than 1 degree. Glaciers are melting. Extreme weather events are multiplying. And the question that report posed still has no definitive answer: can an economy grow without end on a finite planet? In the 7 previous episodes we have walked through the great isms: capitalism, liberalism, socialism, communism, the welfare state, neoliberalism, libertarianism. Each proposed a different way to organize the economy. But all of them shared one premise: economic growth is the central objective. More production. More consumption. More GDP. The differences were in how to distribute that growth, who should control it, how much the state should intervene. But that the economy should grow was, for all of them, a near axiomatic truth. Ecological economics challenges that premise. And it does so with arguments that deserve to be taken seriously, whether or not they come from the mainstream. Conventional economics treats nature as an input. Raw materials that enter the production process, waste that comes out. The environment is external to the economic model. That is why they are called externalities, because they are outside the analytical framework. Ecological economics inverts that logic. The economy does not contain the environment. The environment contains the economy. All economic activity occurs within the biosphere, uses resources from the biosphere, and generates waste that the biosphere must absorb. The economy is a subsystem of a larger system that has physical limits. This idea has roots in thermodynamics. Nicholas Georgescu-Roegen, a Romanian mathematician and economist, argued in 1971 that the law of entropy applies to the economy. All productive activity transforms matter and energy from low entropy, useful resources, into high entropy, unusable waste. This process is irreversible. You cannot unburn a barrel of oil. You cannot rebuild a felled forest in a generation. If resources are finite and degradation is irreversible, an economy that grows indefinitely is physically impossible. This is the central thesis of ecological economics. Not an opinion. An argument based on the laws of physics. The conventional economic response to the limits argument is technology. Innovation allows us to do more with less. Energy efficiency improves. Materials are substituted. Renewable energy replaces fossil fuels. Growth can be decoupled from resource use. This argument has partial evidence in its favor. The energy intensity of GDP, the amount of energy needed to produce €1 of output, has decreased in most developed countries. We produce more with less energy per unit. But here a paradox appears that the English economist William Stanley Jevons identified in 1865. When efficiency improves, the cost of using a resource falls. And when the cost falls, total consumption tends to increase. Cars are more efficient than ever, but there are more cars than ever, and people drive more than ever. Computers consume less energy per operation, but operations have multiplied by millions. This is the Jevons paradox, or rebound effect. The empirical result is that relative decoupling has been achieved: more GDP per unit of resource, but absolute decoupling, fewer total resources with more GDP, has not occurred at the global scale. Carbon emissions have continued to grow in absolute terms. Total material consumption keeps rising. Technological optimists point out that we are in a transition and that renewables, the circular economy, and artificial intelligence can achieve absolute decoupling. Ecological economists respond that we have been waiting 50 years for that transition and that the data do not confirm it at the scale necessary to prevent environmental collapse. It is a genuinely open debate. Neither side has definitive proof. If infinite growth is not possible, what is the alternative? Herman Daly, considered the father of modern ecological economics, proposed in the 1970s the concept of a steady-state economy. An economy where physical production remains constant at a sustainable level, but quality of life can continue to improve. Less quantity, more quality. Fewer things, more well-being. The degrowth movement goes further. It does not propose maintaining the current level of production, but deliberately reducing it in wealthy countries so that the planet can sustain a decent standard of living for everyone. Serge Latouche and Georgios Kallis are two of its most influential theorists. The degrowth argument is direct. Rich countries consume resources at a level that cannot be generalized to the entire planet. If everyone on Earth consumed like an average European, we would need almost 3 planets. Like an average American, 5. Growth in rich countries has been achieved at the expense of resources that should be available for poor countries and for future generations. The criticism of degrowth is equally direct. Reducing production means reducing incomes, employment, and tax revenue. How do you fund public services if the economy contracts? Who voluntarily accepts being poorer? What government can win elections with a degrowth platform? Ecological economists respond that degrowth does not mean impoverishment. It means reorienting the economy toward what truly matters: health, education, leisure time, relationships, nature. GDP measures production, not well-being. A traffic jam increases GDP because more gasoline is consumed. A divorce increases GDP because it generates legal fees. That does not mean we are better off. In 2017, the British economist Kate Raworth published Doughnut Economics, a framework that attempts to reconcile planetary limits with human needs. The idea is visual. Imagine a donut. The outer ring represents the ecological ceiling, the planetary boundaries we must not exceed, such as climate change, biodiversity loss, ocean acidification. The inner ring represents the social foundation, the minimums every person should have, such as food, health, education, housing, political participation. The safe and just space for humanity lies between the 2 rings. Inside the donut. The goal of the economy should not be to grow without end, but to get all of humanity living within that space. Raworth does not propose a specific system. The critique of growth as an objective naturally leads to questioning how we measure economic success. GDP, which we covered in Part 7, measures total production of goods and services. But it does not measure distribution, sustainability, health, happiness, or environmental degradation. Bhutan introduced in 1972 the concept of gross national happiness as an alternative to GDP. The indicator measures psychological well-being, health, education, time use, cultural diversity, good governance, community vitality, ecological diversity, and living standards. It is a fascinating experiment, though its applicability to large, complex economies is debatable. The United Nations has published the Human Development Index since 1990, combining income, education, and life expectancy. It is better than GDP alone, but still does not capture the environmental dimension. The search for an indicator that integrates human well-being and environmental sustainability continues. It is not a trivial technical problem. What we measure determines what we prioritize, and what we prioritize determines how we live. For a family in a wealthy country, ecological economics raises uncomfortable questions. Do we really need everything we consume? Could we live well with less? Are we sacrificing our children's future for our present comfort? For a family in a poor country, the question is different and more urgent. They need to grow. They need to escape poverty. Telling them that growth is bad when they have never had enough is, at the very least, problematic. Degrowth, if it happens, should start with those who consume the most. Climate justice is the hardest social dimension of the debate. The countries that have polluted the most historically are not the ones suffering the worst consequences. Those that have emitted the least are the most vulnerable to droughts, floods, and extreme events. Resolving this asymmetry is as important as reducing emissions. 3 ideas to take away from this episode. First, ecological economics argues that the economy is a subsystem of the biosphere, not the other way around. If resources are finite and degradation is irreversible, infinite growth is physically impossible. The Jevons paradox shows that technological efficiency does not guarantee a reduction in total consumption. Second, the alternatives to growth, daily steady state, Latouche's degrowth, Raworth's doughnut, propose reorienting the economy toward well-being within planetary boundaries. They are intellectually coherent but politically difficult. No country has implemented degrowth voluntarily. Third, the debate between green growth and degrowth is unresolved. Technological optimists bet on decoupling growth from resources. Ecological economists say the data do not confirm it. This is probably the most important economic question of the 21st century, and the answer will affect every person on the planet. We have walked through the isms from capitalism to ecological economics. Each one tries to answer the same question: how should an economy be organized to serve human needs? In Part 13 we will see how governments do it in practice, the tools, the policies, and the inevitable trade-offs when theory meets reality.